Alright, in this video I'm going to introduce you to physics, and I'm going to discuss a unit system that we're going to use to deal with measurements in our study of physics. Alright, so let's get started. So what is physics? You might know what chemistry and biology and other sciences are, but you might have trouble defining what physics is, and that's what I'd like to help you with. So let's start with, not with physics, but we'll start with what you might know already. So if I asked you what biology studied, you might say it's the study of life, and you would be correct. And if I asked you what chemistry studied, well, it's the study of chemicals. All right? But what in the world is physics? Okay, here is the way to understand how physics fits into the puzzle of all these different flavors of science. All right, so let's say that you wanted to be a doctor, a medical doctor, or a zoologist, or a veterinarian. All right, so you would clearly have to study biology. So let me make a box called biology. So you would be studying biology to be the best medical doctor, veterinarian, zoologist, pharmacologist, whatever that you could be, right? Okay, so then suppose one day you woke up and you said, you know what, I don't just want to be an average biologist, I want to be the best possible biologist. So then you might think, okay, I really want to understand life. Okay, so let's get down to the fundamentals. So you would quickly discover that all life, including yourself, your body, is made of, well, stuff, and stuff is, well, chemicals, right? So in order to really understand life, you would find yourself studying chemistry, wouldn't you? All right, so it would be correct to say that in fact biology is based on chemicals. Okay, so chemistry is you might say the chemicals are the foundation for life, right? All right, so then that's a little bit more fundamental, a little bit core, more that's the core of what you're studying. So now you're studying chemicals, so you're that much better of a biologist. And then one day you tell yourself, you know what, I really want to even go another extra mile. Okay, so let's think. If we really wanted to now understand chemicals really well, what would we do? Well, chemicals are made of, you may have heard the term molecules, maybe you've heard the term atoms. You know that chemicals have energy. Okay, so now you're getting into something more fundamental, the nitty-gritty of atoms and how they move and energy. All right, so that's some kind of foundation for chemistry, right? Well, now you're getting into what physics is. All right, so physics, you might say, is the foundation for all the other sciences, all the other natural sciences. Maybe not psychology and economics and what we call soft sciences, but the sciences like what I've mentioned here, biology, chemistry, physics, these are definitely biology and chemistry are definitely based on physics. Okay, so think of physics as like the core, the when you really get down to it, what's the fundamentals of science and nature. Okay, so that's my definition of physics. So let me now put that here. So let's put finally physics, the study of the, for lack of a better word, the fundamentals of nature or science. We'll just put the fundamentals of nature. All right, God's creation, you might say. Okay, so we're going to get to the core of everything. So this will help you for all of your other whatever you want to do. If you want to be a doctor, a chemist, physics will help you in all those areas. All right. Now, what about engineering? Maybe you want to be an engineer. How does that fit into the picture? Well, engineers use there's biomedical engineers, bioengineering, so they use biology. There's certainly chemical engineers, and there's engineers that use physics principles. So engineering is kind of a layer that something like this. So engineering is a layer that depends on everything we've mentioned so far. So I'll put a layer that kind of touches all the layers below, and I'll call that engineering. But I think it should be clear that everything is touching physics, or everything is resting on physics. All right? So that's my introduction. So physics will help you to think more critically, to understand things at a deeper level than you may have ever understood them before. These are some reasons why people study physics. All right? Now, let me give you some advice about tests. Now, in biology and chemistry, if you've taken those classes before, or any other science class, you can sometimes get away with simply memorizing formulas, and then when you take tests, you plug in numbers. All right. Physics is not like that. In physics, we're trying to push you to really understand things instead of just becoming an equation monkey that can plug in numbers. So the tests will intentionally try to get you to think rather than just plugging in numbers. Okay? Let me now change subjects and talk about a basic unit of measurement. So all of these sciences, not just physics, rely on measurements of things in nature, such as the length of something, the temperature of something. All right? And so what we use, if you live in America, you've probably got used to using units like miles and pounds and yards, all right, hours, okay. All of those units they're clearly defined, but they're not the units that scientists use. Why is that? Well, scientists use this very nice unit system that was originally developed by the French a couple hundred years ago, and it used to be called the metric system, but now the metric system has gone through a few iterations, some improvements, and so today we know it as the international system. Now, if you were to say the international system in French, you would say Système International or something like that. So the acronym in French for international system is the SI unit system. All right. So you'll see me refer to the unit system we will use it in this class as the SI unit system. Okay. So what are some examples of units in the SI unit system? Well, glad you asked. So suppose we wanted to measure length. That's one thing we can do in the SI unit system, and what we do to measure length is we use meters. Okay, a meter is about, if you were to stretch your arms out like your Jesus on the cross, a meter is about the length from one of your hands to the other hand. Okay, that's a meter, roughly. Okay, what about time? Time, we will use seconds. All right. Now, we all know what a minute and an hour and a day and a year is. All right. But if we had our druthers, whenever we need to use time, we will really encourage people to use seconds. Okay. That's the SI unit of time. And then mass, how much stuff is there? Okay. You may refer to the amount of stuff, you may sometimes call it weight. You might think that it's measured in pounds. Okay, that's not an SI unit. So to measure mass, we use kilograms. Now this one's a little strange because it has a prefix in front of grams. You might say, why don't we just say grams? Grams is certainly a valid unit in the SI unit system, but it's not one of the core units. So when you want to give a mass, it it I mean it wouldn't be wrong to give an answer in grams, but when I say the SI unit system, the first choice is kilograms. All right. So length, time, mass. Now that's only 3. There's other units that I haven't mentioned, but they're not used as much, especially in this class. Okay? So is that all we're going to do is measure length, time, and mass? Well, no. What we're going to do is for other types of measurements, we can combine these to get new units. For example, suppose I wanted to measure area. Okay, I have meters for length. What I can do is multiply meters by itself, or I can square the unit of meters, and that would give me square meters or meters squared. That's the unit that we use for area. Do you see how I was able to recycle one of the old units I've listed here in blue? All right. For volume, likewise, we cube meters, so we measure volume in cubic meters. Later on, we'll learn about speed, velocity, and that's going to be a ratio of length units divided by time units, length over time, meters per second. Okay, so you could do ratios, products. There's lots of ways that we will combine these units to get new units. Okay, so a meter, I told you roughly the length of it. I know you know what a second is, you know what a kilogram is. What if we want to measure something much, much larger or much, much smaller than these fundamental core units? Then what do we do? All right. Well, you can, in the SI unit system, they have standard prefixes that you can use. All right, and I will list the most common ones now that we will be using. There's other ones that are for even more extreme situations, but if you have, let's say, 1,000 meters, you can put kilo in front. Kilo stands for 1,000. You can also have kiloseconds. All right, and you can see already I have kilograms. Okay, if you have 1,000,000 of something, that is a mega. All right, that means 1,000,000, 6 zeros. If you have 1,000,000,000 of something, that is a giga. That is 9 zeros. Okay, and that's enough. If you're curious, the next one would be tera, but we won't be using that one too much. Okay, so now let's go in the other direction. What if you had not 1,000 of something, but 100? So then the prefix is centi. And now let's go smaller than even 1 meter. Okay, if you had centi, no, what I meant to say, centi is not 100. 100, what I meant to say was centi is 1 meter divided into 100 pieces. All right, that's what a centi is. Now, what if you chopped a meter into 1,000,000 pieces? That tiny length would be what a milli is, a millionth. Excuse me, a milli is 1,000th. All right. If you chopped it into 1,000,000 pieces, that's the prefix for that is micro. All right. And then we'll chop something into 1,000,000,000, and then we will stop there. So to chop something into 1,000,000,000, we put the prefix nano. And that once again has 9 zeros. Okay, so you can talk about nanoseconds. A nanosecond is about how long it takes a computer to do a single simple calculation. That's where nanoseconds get used. Let's see, a kilometer. It takes a kilometer. That's if you're going to run. You know, like if you go jogging, you might jog a handful of kilometers. That's another way that's used. A centimeter is about the width of your thumbnail. All right. A millimeter is about the length roughly of a grain of sand, maybe a little bigger. Okay, and then we can, of course, you can have nanograms, kilograms, megagrams, etc., etc. And there's also some abbreviations you should know about. So let me write those. So meters, we will often simply write m instead of lowercase m, and the case is important. For seconds, we will use lowercase s. For kilograms, lowercase kg. And then the prefixes. So what do you put in front of those green abbreviations to signify that you want to include a prefix? For giga, we are going to use, watch this, a capital G. See that? Now, that's why I said case is important. For mega, we're going to use a capital M. For kilo, we're going to use a lowercase k. Centi, lowercase c. Milli, lowercase m. Let me skip micro for a second. For nano, lowercase n. And for micro, milli already stole the lowercase m, and mega already stole the uppercase m. So we're going to have to reach into the Greek alphabet, believe it or not. And the Greeks have a letter called mu that looks like a fancy handwritten U, something like that. MU is how you spell that letter. And that's what we use for micrometers. Alright, so let me finish this video now by showing you some conversions. And I'd like you to pause the video after I ask the question to see if you can do these. Alright, see what you can do with these. How many grams are in 5 gigagrams? How about that? How many nanoseconds are in 102 megaseconds? And let's see, how about how many kilometers are in 72 micrometers? All right, see if you can answer those. This will show how well you understand exponents, and you could deal with exponents and knowing when to multiply and divide, and maybe you do that on your calculator if you want. But try these, and then I'll show you how to do these. Alright, so for the first one, 5 gigagrams. So the first thing I would do is write that. That's 5 billion. That's 5 billion grams. And so right away, once you convert giga to billion, you're done, aren't you? So the answer is there's 5 billion grams. Now, if I was to ask you how many kilograms, right, that would be a good question too. Can you tell me how many kilograms are in 5 gigagrams? Okay, well, I just told you that there's 5 billion grams, and we know kilos are bigger, so we're going to have less than 5 billion. In fact, we're going to have 1,000 times less if we want to know how many kilograms. So what I would do is I would take 5 billion and divide it by 1,000. That you want to do exponents. So 5 billion is 5 times 10 to the 9. Divided by 1,000 is 10 to the 3. That's probably the easiest way to think about this. So 5 million kilograms. Okay? Let's do the next one. How many nanoseconds are in 102 milliseconds? So the first thing I want to do, even though that I didn't ask this question, is figure out how many regular seconds there are. So that's 102 million seconds. Right? Now, I know that there's going to be more nanoseconds than there is seconds. In fact, we know that in 1 second there's a billion nanoseconds. Okay? So if whatever quantity of seconds I have, I simply multiply that number by a billion. Alright? So I'm going to take my 102 million, write it as in write it with an exponent. So there's 102 million. Now I'm going to multiply that by a billion. A billion is 10 to the 9. And so 102 times 10 to the 15 nanoseconds. All right. And then the last one, how many kilometers are in 72 micrometers? So 72 micro, and you can see that I'm always converting to the fundamental unit. Okay, for the second question, I converted to seconds. For the first one, I converted to grams, although the fundamental unit of mass is kilograms. So that one was the exception. For the last one, I'm going to convert to meters. So 72 micrometers is 72 times 10 to the minus 6 meters. Okay, now I want to convert to kilometers, so I'm going to have less kilometers than I do meters. So what I'm going to do is I'm going to divide that number by 1,000. So that gives me 72 times 10 to the minus 9 kilometers. 72 billionths of a kilometer. Okay? Now, if you are having trouble understanding the conversions, let me give you a trick that you could use to help you with these. Think about multiplying fractions, and you know you're multiplying when you should be multiplying, and dividing when you should be dividing if the units cancel out the way you want. Okay, that was a mouthful, so let me show you what I mean. So let me do the first one at the bottom of the screen. All right, so I have I started out with 5 billion grams. Now I know that there are this is converting to kilograms. So I know that there is 1 kilogram per 1,000 grams. Okay, so I'm allowed to multiply by this ratio because this ratio is just 1, and we all remember from math that you're allowed to multiply by 1, right? Now, why didn't I multiply by 1,000 grams divided by 1 kilogram? All right, that's also equal to 1. Okay, well, because I want my answer to be in kilograms. Notice that the way I've written it, the grams cancel, and so I just have 5 billion divided by 1,000, and then I have my desired units on top. You see that? That's what you want. You know you're doing the right thing, multiplying or dividing, if you've got the right units on top. Okay? Now, let's do the second one in a similar fashion. Again, if this helps you, you can use it. If it doesn't, just drop it. For the second one, I had 102 million seconds. All right, and now I'm going to multiply by something with nanoseconds. So I want the answer to be in nanoseconds. So I'm intentionally now going to multiply it by a ratio that has nanoseconds on top. Okay, so how about the number of nanoseconds in a single second? So 1 second on bottom, and I know that 1 second is 10 to the 9 nanoseconds. Again, you see how I knew that I wanted the answer to be in nanoseconds. That's why I put it on in the numerator instead of putting nanoseconds in the denominator. Okay, so now the seconds cancel. So that's how I knew that I had to multiply by a billion, by 10 to the 9. Okay, and so all of the unit conversions will be that way. All right.